and pay a 10% annual coupon. Bond L matures in 15 years, and Bond S matures in 1 year. Assume the value of each bond be. What would the value of each bond be with the going interest rates 5, 8, or 12%? Assume that only one more interest payment is to be paid on Bond S at the maturity of 15 on L. So here we've set it up. We have Bond L and Bond S. We have our 15 years for N and 1 year for S. Our payment is our coupon rate times our par value. So in this case, our payment is $100 and our future value be $1,000, and the same for Bond S. So let's find the present value of Bond L at 5%. So we're going to find our present value, and we're going to use our rate, and then we're going to periods per year or periods, and let's lock that because we're not going to want that to change at all. So push F4, and that locks the cell. When you put a dollar sign in front of each reference, it locks the cell. Our payment is 100, and let's push F4 on that, lock that, and our future value, payment is 100, lock that, and our future value is 1,000, and let's lock that. And we'll say OK, and let's get our negative sign out of there, make it positive. So there's our present value. Now since we have the formula, we can just drag it down, and for both, and fills both of them in there. We have our present value for Bond L is 1,518 and 1,171 and 863. So now we can do the same thing for Bond S. Let's find our present value. Our rate. We're not going to lock it because we're going to use the same trick, copy it down, and we want it to change our rate every time. Our periods per year, we do want that locked. We don't want it to move down as we move our formula, as we copy it down. So we'll keep it. So we'll just push F4, and that locks it. And we'll find our payment, and we want F4 that, we'll lock that, and the same with our future value. Okay, and let's make it positive. So now we can just copy it down, and we find that our present value for the shorter year bond is 1,047.62, 1,018 at 8%, and $982 at 12%. Okay, now let's look at these for a little while. What does the longer term bonds price vary more from price than the shorter term bond when the interest rate changes? Okay, let's look at these bonds. Let's first talk about it. We know we have our coupon rate and we have our par. Okay, anytime that the bond is higher than par, it's called a premium. So both bonds are selling at a premium. But notice that when it sells below coupon rates, when its present value is lower than the par value, it's a discount bond. And you'll see that now also notice when the yield to maturity is lower than the coupon rate, it's a premium. but when the yield to maturity is higher than the coupon rate, it is a discount bond. So why is a 5% 15-year bond sell for $1,518 and just a 1-year sells for $1,047? Well, let's think of it this way. If I bought a bond for 15 years at the rate of 10%, and the next day the coupon rate or the opportunity cost of capital went to 5%, all of a sudden my bond would be worth $1,518.98. I've made a good deal because interest rates are down, but I've got them locked in for 15 years at 10%. Now let's say I just bought a 1-year bond at 10% and interest rates went down. Well, my bond is worth more, but not near as much more. That's because in 1 year I have to renew that bond. Okay, and if the rates are at 5%, I can't renew it, but at 5% I won't be able to renew it at the 10. So you can see the interest rate risk playing a part in the price of these bonds, and the long-term bond shows, has more interest rate risk, and the short-term bond has more reinvestment rate risk. As you can see, interest rate risk shows up on this discount bond. If I bought a 10-year or a 15-year 10% coupon bond and the next day rates went up to 12, I didn't do a very smart thing. I could have got 12% if I'd have waited a day. So see, my bond is worth less. No one wants to buy it. They can all lock in their rates at 12.